subsequence. Right? Everybody understand what the problem is, more or less? Right? I mean, you could also grab the 8, 9, 10, right? But then, I mean, I guess you could do 1, 8, 9, 10, but that's not as long. Right? All right, so if we're going to progress with this in our normal sort of fashion, we would say, all right, so and the cost is the length of this sequence. So really, if anything you don't fully understand, ask. Does everybody understand what the problem is? Anybody have any doubts about the problem? All right. So we think about asking a bird a question. We're given this input, and she has the subset which is longest. What's the obvious question to ask her?
What's the last one inside of it?
Right. We look at this 9 here, and we say, do we include it or not? Right? So if she says, don't include it, then what do we do? That's the easy case. We just drop the 9, we give the rest to the friend gives us our answer, and then what's our answer? It's the same, right? Because we've ignored the 9. That was a good trick there. Now the hard part, if she says take the 9, right? Then what do we do?
We check the friend's answer.
Right? We could drop the 9, right? And now we could ask the friend for the longest common subsequence, right? And what is he going to say? Well, he might include the 10 in it, right? So what's wrong with if this solution contains the 10?
You can't add the 9.
You can't add the 9, right? So what do we do instead? Yeah, so that certainly is an option. That's a good thought. So what do we do? Is we remove, what do we remove? Everything that's bigger?
Or equal.
Or equal. Everybody that's bigger, yeah, I guess if we're doing strictly increasing there, good, right? So you can remove these guys. Not the 8. Which is bigger? Now, there's something we're doing right here that should start by bringing fear into you. Is anything here, anybody afraid of something?
Not a prefix. I think the substance is not a prefix.
Right, it's not a prefix. And what's the danger of it being not a prefix?
We cannot use the dynamic program to create the table.
And why not?
In some instance, always changed.
Right.
This is an NP-complete, not the dynamic.
Right. So if your subinstance is a subset, what's the danger?
I think we cannot get the complete the set of subinstance.
Right. So the danger is that there are too many of them.
Yeah.
Right. There are too many subsets, and that if you had to make a table indexed by all the subsets, right? If you had a little square in your table for every subset, then you would be too many of them, right? You'd have 2 to the n subsets, right? So now if we look at this, I've actually never really thought about this problem quite this way, but it's kind of interesting. Is this an arbitrary subset? Why no?
Because you're always at least deleting the last one, right?
Yeah, but we're deleting kind of arbitrary guys in here. Right? Are they arbitrary guys that we're deleting? Why didn't we delete the 8? Could we have deleted the 8?
No.
Why not? because it's not less than 9, right? It's not bigger than 9. So in some ways, we're not deleting an arbitrary subset. We're deleting the guys who are big, right? So if we're talking about how many subinstances will arise, we can almost name the subset by naming the value that we've deleted down to, right? Like we could have this as our instance, and then we have another instance which says drop the 9, and then the other instance would say drop the 10, and then the next instance would be drop the 10 and the 9, and the next instance would be drop the 10 and the 9 and the 8, right? And then the 10, the 9, the 8, and the 7, right? So in that case, how many subinstances do we have? Yeah, because in some ways it's the number of subinstances equal to the number of numbers here, right? Because I'm never going to say drop it down to 11, because that doesn't do any difference. But we're gonna do this. I mean, I think that would be a good solution, and we could go through it and do it. But let's not do it that way. Let's instead say sometimes it's useful when if you change the problem, right? And let's change the problem to saying that the input is a sequence of numbers. The instance is a sequence of numbers and a particular number, right? So say this number right here. And the solution is an increasing subsequence that ends in this last number, in this. All right, so if the Berge says, yes, take it, right? Then what we're looking for is a sequence that definitely ends in the 9. Right? Now why does that matter? I mean, I guess another way of thinking about these problems is as more of the input, right? We want our subsequences to be prefixes, right? So we're going to look at longer and longer prefixes. We want to say, I mean, suppose that we're coming down here and you want to keep, what information do you want to keep before you've looked at the rest of the number, the rest of the strings, right? You say, well, look at, I have a 1, 2, 9, right, or a 1, 8, 9. Those are all pretty good. That's the longest string. But I might prefer to keep just the 1, 2 and not include the 9. Why? For the future? Right, because it's a smaller number, right? Because then I can grab the 4, 5, 6 later in the future if they're there, right? So another way of thinking about it is if a friend is going to be given this, and I'm going to get the friend to help me give me as much information as useful, then I might want to know, right? What's the not only the longest sequence, but the longest, given any value v, I might want to know what's the longest sequence that ends in v, right?
When you say that you want the subsequence to end with the ith number, which is in our big one is 9, our friends are going to have one who says, okay, if our friend is given that instance, you would say that give me something that ends with 9. But what if you, like what you're saying, like what if there's other ones in between, that wouldn't that not work?
All right. Well, let's finish this thought here. Hold that thought. I mean, can you say that if for every value v we say what's the longest sequence ending in v, then you'll have that to say, oh well, if later it's v plus 1, v plus 2, then I'll be able to go. Now, do we matter for every value v? Well, we only care about the values that are in here. Right? So if I knew stored what's the longest string ending in 9, and what's the longest one ending in 2, and what's the longest one ending in 3, and so forth, then that would be enough information. So, in some ways, this dynamic programming algorithm is sort of less of the bird-friend idea. But suppose we had a table here, and in each index I, we're going to store here the length of the longest string, substring, of A1, A2 up to AI, ending in AI that is increasing. All right? So what our sub-instances are all the prefixes, right? And the problem that we're going to be trying to solve is the length of the longest sequence with the extra requirement that it ends in that character, right? And that's increasing. Everybody understand what we're saying here? Now the bird-friend algorithm is easier, right? Because here, let's say, now I want to fill in this square here, right? I know my string is this. It's A1 through AI, ending in AI, right? So now, what should I ask the bird? I already know AI is in there, right? If I asked, well, I can't ask, is AI in it, because I already know the AI is there. Knowing that the previous one is not in there isn't so useful. All right, what happens if she told me who right, we know this guy's in there. What happens if she told me that the next character that's in the string is some AJ? All right, so let's, all right, she tells us what the second last character is, right? So we could write up here what the thing is, right? Maybe it's 8, 3, 2. So forth, right? We want to know the longest string ending in 4.
What did we actually ask them? Did we ask them what's the second last?
The second last. All right, so we want to know the longest sequence increasing that ends in 4, and so we could ask her what's the longest one, what's the second last guy in our answer, right? And what is the longest thing ending in 4? It's probably 1, either 2 or 3, 4, right? So she might say the second last one is 3, right? So what's the friend giving? What do we know then? We know it's a sequence that ends in 3 and then has 4 in it. How are we going to get the longest, this part of the sequence, the rest of the sequence? Right? This friend here, what is it telling us? It's telling us the length of the longest sequence ending in 3. Right? So what if we get that from our friend, the longest one ending in 3, then the longest one ending in 4, consistent with that bird answer, would be what? It's just his answer plus the 4. Right? Does that make sense? People with me here? Anybody not with me here?
I understand what you're saying, I just don't understand why it's useful. Why would you want to know?
Why do we need to solve this problem at all?
No,
Or
I mean, why,
the longest one ending in 4?
yeah, then looking at 3, and then figuring out that 4 is just 3 plus 1.
All right. Well, so let's jump to the top level. My goal is to find the longest string ending in anything, right? So suppose I filled this table out this way.
Okay.
How do you find the longest string ending in anything?
It's the number that's the largest.
It's the number in this table that's the largest, right? Right? The longest string is either the longest one ending in this, or it's the longest one ending in this, or the longest one ending in this. Right? So after I fill out the table, all I have to do is scan through here once, and I'll know that the longest one overall is the one that has the biggest number. Right? I can't hold on to my chalk today. Does that make sense?
Right, but then once you've done that, right, what if they want the actual sequence, not just the one that the last?
Oh, all right. Well, then we'll get to the point of, well, we'll also store in here the bird's advice, and then you can
The bird will go, okay.
then you can reconstruct it. Right? So what we would do here is if the bird says, all right, so now let's do that. How would we fill in this entry? Well, we would say, hey, bird, what's the previous character? But we don't have a bird. So we would loop over them all. Right? If the previous character said, if the bird said the previous character is 1, then our length is going to be, right? I mean, let's fill in this table here. The longest one from here is 1. The longest from here is 2. The longest from here is 2. The longest to here is probably still 2, right? To here, you can do 1, 3. You can do any of these and then the 9, right? So it's 3. And then here, it's only going to be 1. Right? People buying that? So now I want to know the longest to here. Well, it's either 1, 4. If it's the previous one is 1, then this is going to be a 2. Right? Let's put our various options here. We get a 2 here, or we get here. What's this one's going to give us? 3, 4, 2. Right? So what are we going to put in here? That the answer is 4, and the bird's advice is to go over here.
3.
Oh, 9 is not less than. Oh, right. Good. Well, that's where you also have to pay attention. Right? So you also have to come along here and check to see if it's possible. Right? If the bird says that the previous character is here, then you say, no, bird, you're wrong. Right? So let's do this again. You know, here the bird isn't completely lying. Right? It's not completely foolish, because it could be here, in which case you get the 2. And here it's impossible. Here it's possible and you get a 3. Here it's possible and you get a 3. Here it's impossible. Here it's possible and you get a 2. Right? So the answer is 3, and you can go back to one, you point to one of these possible earlier guys. Does that make sense? And then when we want to fill in this one, the 10, we say it's possible we would get a 2, possible, 3, possible, right? These are all possible. We get a possible here, we get a 4. This comes back to there. Right? And then maybe what are our, maybe we have a 1 here. Well, what's this going to give us?
1.
Well, in some ways, none of them are possible, right? So it's kind of like the default. Maybe we put a 0 here. That's possible. So we get a 1, right? We keep filling this table out, and then when we're done, we go back and say, okay, which is the biggest number? Right? The biggest number here is this, and then we follow the length back. to give us our sequence? You know what my guess is? Is that the people in the room here who understood dynamic programming before we walked into class understood this, and the people who didn't understand anything, and so we didn't really help anything here. That's my suspicion. Should we could write the code on the board, we could do another one, which would be just as confusing. What do people want to do now? We could go over this again?
Do another one.
How many people want to see the code for this? All right, we can do it real quick. Code's quick. See, the advantage of this course, in my opinion, is you want to be thinking abstractly before you start coding. And you have the big picture of how it works and that it's going to work. And then the coding's pretty straightforward. So, longest increasing subsequence, right? The input is A1 to AN. The output, I guess this is kind of like a postcondition, is the longest common subsequence, right? And then we have a table. How many subinstances do we have? N. Let's index it from 0 to n to make this will be the empty string, right? Because that'll give us our 0, which will help with bootstrap future ones, right? And then what we put a little comment here is we got cost and Berge's advice. Cost I is the length of the longest common, what do we want here? Longest increasing subsequence. Longest increasing sequence ending in AI. Right? Everybody understand what we're storing here? Right? And now we do base cases. What should our base case be? Yeah, all we need is cost of 0. What's the longest common subsequence of this?
0.
Clearly 0, right? And Berge's advice is it doesn't really matter, right? We're not going to use it. We need a bigger piece of chalk because I keep dropping those. All right, so now what do? What's the next thing we do in every code? Everybody should know, right? Our goal is to fill out that table, right? So we loop over subinstances. And in order so that nobody waits, what order should we do it? I equals 1 to n, right? So our goal now is cost I, which what is that? Right? That's that up there. You know, you should either write it here or you should write it here. Doesn't really matter. You don't have to write it twice. All right, so now my goal was to fill in that one square. So how do I do that? We asked the Berge question. Loop over Berge answers. And here we're going to say loop. What's our Berge answer? It's always k. And what could she answer? From 0 to I minus 1, right? And what is she saying Berge says the second last digit number is AJ. All right, so we know the last one is AI, and the second last one, oh, not J, K, right? She's told, we asked her, what should the second last character be? And she gave us an answer that it was AK. Everybody good there? Now what we're looking for, now goal is to find the longest increasing subsequence ending in AKAI. Right? Everybody with me here? So how are we going to do it? We're going to ask a friend. What do we do? What do we ask the friend?
Find the longest increasing sequence from...
What's our input? We want the longest increasing subsequence of A 1 to A K. And what needs to be true about that longest? It has to in AK, right? And where do we get our answer from? Cost K conveniently gives that to us, right? Now what's the length of our sequence? It's one longer, right? Now, where should we store this?
In the table.
Not yet, because we don't have, in the table, we store the longest overall, right? Right now we're just looking at the longest one that's consistent with this bird answer.
So then you do it for all the birds.
We do it cost K, right? Now, everybody good with that? What am I missing?
The bird advice.
Bird's advice was up here. We have to check something.
Check that the bird's advice is not bigger than yours.
Right, we had to check to make sure the bird's not completely out to lunch. If AK is actually smaller than AI, then we do this. Right? Then we say, oh, then the longest sequence ending that ends in this is going to be the longest one ending in this plus 1. Right? What's our else? What happens if this is not the case?
Cost equals negative infinity.
Negative infinity, exactly. In fact, in this case, probably, negative 1 would do the trick. Because we already have a 0 somewhere, right? Everybody got that? So then we try each bird answer. Right? What does that give us? That gives us the longest answer to our problem of those ending, those consistent with the bird answer. Right? Does that make sense?
Question.
Yeah?
You're looping through, right? But your cost K is holding the value. When it loops again, the cost K is going to be overwritten.
This is
It's like an array.
This is like an array. Now, the truth is that if you're coding this up, would you have to store them all?
No, you just check. We keep track of the longest ones.
You keep track of the best as you go, right? But I wrote this code because to, I don't know, to think about, to help us clean it up a little bit. Right, so at the end here, we end the loop over K, and now what do?
We pick the max.
We take the best of the best. K max equals argument max of cost K, right? It's the K that maximizes this thing, right? And then cost I. Now we're ready to store the longest sequence ending in AI. And how long is that? That's this cost K max. And the Berge advice is what? Is K max. Right? And then, and now we're done. Right now we're done this value of I, and we go to the next value of I. Everybody got that? Now in the end, when we filled out this table, what our goal was is to find the maximum string that ends in anything. Right? So how are we going to find the maximum string that ends in anything? Remember, we find the biggest one in the table. Right? So we're going to say K max equals R max cost K. Now I guess that's why I, of course this cost is a different array than that one, right? This isn't a, that was just sort of a local variable. Right? Here we're finding in the array what's the biggest one. And then that would tell us, right, if this is the K max, that the longest string ends in this. Right? And what's the second character in the longest string? Right? We follow the Berge advice. Right? Back.
This is like part 2 of the. This is like going again once you found.
This is what we, yeah. This is like redoing it afterwards. Right? There's this extra. In this case, there's this extra step, right? Because we weren't quite solving the problem we wanted. People understand this code? How many people feel they could do code like this? How many people think they could not do code like this? What can we do to get you to do code like this between now and Monday? I mean, do you have a question? I mean, you see how all the codes are the same, right?
Yeah, it seems like same step.
Right. What are the issues? The issues are what's the list of subinstances, right? Because you have a loop over subinstances, and then there's a loop over bird answers, right? And then there's how do you get the best solution to my problem consistent with this bird answer from my friends, from asking my friends, right? So those are the three hard things, right? And that's why I did something which no one else has done, which is abstract to this bird idea, right? So I say what you first do is say, suppose I have an instance that I'm trying to solve, right? What are the things that I try, right? What is this loop going to be looping over? And then, if the bird, I assume the bird tells me why, because I'm somewhere in this iteration. And now I'm looking for the best answer to my problem, consistent with what the bird has said. Right? So then I have to ask my friends for advice, right? So that I construct a subinstance that my friend's going to help me with. And how is my friend's solution going to help me find the best solution consistent with that bird advice? Right? And then once you know who your friends are, then you can go up and say, what is the set of subinstances that will arise, so you can define your table. I don't know what else to say. What would be helpful now? What would be helpful for you?
Another example?
Another example. You want another example?
Yes.
I still can't hear you.
Algorithm.
Bellman-Ford algorithm. Is that the one we did last class?
What's that one?
So let's just do something similar to like the test. Nothing outside.
Well, yeah, you know, I never remember people's names. You know, I don't know your name. And I don't remember Bellman-Ford's name. Now, I think that might be the algorithm that we did last class, in which case, it's probably harder than you can get on a test. Right? I mean, I'm certainly happy to cover it more, but I think it would be less useful. Let's do let's go through the various algorithms. I mean, you have to make sure you know the algorithms that we've done so far, right? Right, because the one in the test will probably be similar to those. Like, do you understand the longest common subsequence problem? Could each of you write the code for longest common subsequence?
Not that last part right there.
Of the longest common subsequence?
Yeah, because the last part you just did.
Oh, you mean when you refill when you do the table the second time?
Yeah. Yeah.
Well, you could do that, and it's not on the test. So, you know, that last redoing it, if that's what you mean. And I mean, really, I mean, who couldn't do? If the test question was, do this all for longest common subsequence, could you not do? Who could not do it? Yeah. Could anybody not do that one? Could anybody not do knapsack problem?
Maps.
What?
Who can do it?
Who can do it? Could you do it?
Can we go over the context?
The which one?
The context.
Oh, that one's hard. Yeah, don't go there. I wasn't even going to ask that. I mean, we could go over it if you want, but it's.
No, as long as it's not on the So on the test, we would have to give an algorithm and then give code, right?
Yeah. So, I mean, I haven't actually. Sometime I have to actually make up the test, but what it's always said in the past, I think the useful way to do it is to break it into these steps of what would the bird, if you had a bird and you had a friend, where you could ask the bird any little question, and then you could recurse on a friend, then what would you do? Right? Now, in some problems like this one, you know, you change the problem slightly, and I'm never going to make you on the fly change a problem. I would change the problem for you. Right? I would say, for example, hint, it would be useful to instead solve the problem, give me the longest subsequence ending in AI. Right? Right, so then that gives you, and then the second one would be, okay, now if you have this algorithm, and this is your input, what's the set of all subinstances going to be? Right, that's the next step that you have to think through. Right, because you go to someone else teaching this and they don't do these steps, but I claim nobody can write code unless somewhere in their brain they think about these things. Right? You have to think, what am I going to be looping over, trying? So you need a bird question, and then you need to know who your friends are, and you know have to construct your solution from your friend's solution. You need all those steps, right? And then you need to be able to construct a table, so you need to know what the subinstances are. And then once you have that, it should be trivial to write the code down. It's my belief is that if you understand what's going on, you should be able to just write down the code. But, you know,
What do you keep thinking about? When you writing the code is actually easier than explaining what it does?
You know, I have people say that every term, and I've never believed them. Right? I've never believed them. The reason I never believed them is that I don't know anything about you, personally, but the people who say that give me code that there's no way it would work. Not only are their details wrong, but they're completely out to lunch. Right? So that's my belief, right? We have different beliefs. And I'm willing to, test your belief. In fact, I would be willing to say, if you gave me correct code, I won't require you to do anything else. But it better be good code. Right? I mean, there's a threat there. You heard the threat?
So what if it's like one tiny mistake in the code, and that's all you do?
He said perfect.
I know, so then how much do we lose?
Well, yeah, I mean, the truth is I would be a little bit more tolerant of people who sort of do things my way, but I think I'm pretty broad to say, hey, this isn't all going to work, right? Is the, not the details, but is the big picture going to work? And my impression is that after these steps that I require from people are very new for me. I used to be a, everybody, free love, you do it your way kind of guy, and I just got tired of marking wrong answers. Right? So the reason I try to be a dictator is to make life easier for you. I mean, how can you say loop over things that you're going to try until somehow have thought what you're going to try and why you're trying it, right? And how can you construct solutions from your friends' solutions if you don't know who your friends are, right? I just don't know how you can do that, right? Somewhere you have to get the set of subsequences that you're going to loop over. And besides, the truth is, some people, I mean, in some ways, I mean, maybe you're right. Maybe he is right. I mean, on the other hand, different people do things in different ways. And I have had people give the written thing and the code thing to be inconsistent. And then one of them is right and one of them is wrong. And some people have the right one be the written description, and some people have the right one be the code. And so maybe it's possible that people think differently than I do, heaven forbid. All right. 5 minutes. What can we do in 5 minutes? We could really quickly do another one. We could talk more. I mean, are people getting, key is, do you understand the steps that we're putting together here?
A quick question. The optimal solution index K and optimal solution K, what's the major difference?
Oh, they're completely different. They're completely different. All right, so this one is, I'm looking for my goal, big goal is to find what is my instance here, indexed by I, is the instance is the numbers A1 through AI, right? And what am I looking for? I'm looking for a longest increasing subsequence that ends in I, in AI, right? And in here I'm going to store its cost, right? Now, I'm going to come up with a number of different solutions, right? There are those solutions whose second, we're only considering solutions that end in AI, right? But we ask the Berge question, what is the second last number? And so depending on what we try all these ones, right? And that partitions all the strange solutions that end in AI into those that end in A1, A2, A3, A4, A5, right? So, maybe a better notation for this would be IK. If we never wanted to lose, if we wanted to give everything its own name, right? Then what would this be? This would be the length of a solution that ends in I, the best one that ends in I, that's consistent with the kth Berge answer. right? I mean, you're right. That I should have done it that way. I don't know. That would have been better, right? But of course, you're saving all these numbers but once you increase I, you don't need the previous ones, right? So I kind of dropped the I because right? And as pointed out, you don't actually have to remember you only have to remember the best one so far, right? But that would be right. But somehow by giving each one a unique name, you can understand what this guy's what his purpose is. Any other thoughts? I mean, I guess she's coming in 10 minutes. I mean, we're both good standing here, I mean, it'd be great if you could all get perfect on this test.
Expressions like P max is equal to argument of max. Okay?
Can you write that?
Yeah. Are we going to just understand that today?
Yeah. I think so. I mean, that's. Sometimes people put a notation I don't understand, and I have to kind of guess at what it means, and hopefully I always guess right. But this one I've used a number of times. If you have no idea, if you don't think, I mean, I'm not a big programmer, right? So usually, actually, I hate to be embarrassed, but when I don't know it is when they, if they write something weird in Java, sometimes it, I have to think, okay, now that's an object and that's the function, and I get a little confused. But I usually can fake it. I wrote a compiler for Java, right? So now I'm a little bit better in Java at least. Any other thoughts? Should we quit for the day? Let's quit for the day. All right, so yeah, Monday. Monday we'll be back here. We're going to be back here. Some of us are going to be here at 2:30. And some of us will be here at 3:30. And everybody will be happy.
No.
All right, so what do we have left? We have 3 classes, right? At least, one or a half, what?
One's a quiz.
Oh, one's a quiz, so we only have 2 classes. All right, so we're running out of time then, actually. So I want to spend at least an hour on NP completeness, and that leaves 1 hour for review. And as somebody asked at one point, if at least a dozen people show up some date before the exam, I'll come and talk to you. All right.